This is day 20 of Advent of Code 2024 Done and Go. This challenge is called Race Condition. The historians are quite pixelated again. This time, a massive black building looms over you. You're right outside the CPU. While the historians get to work, a nearby program sees that you're idle and challenges you to a race. Apparently, you've arrived just in time for the frequently held Race Condition Festival. The race takes place on a particularly long and twisting code path. Programs compete to see who can finish in the fewest picoseconds. The winner even gets their own mutex. They hand you a map of the racetracks, the puzzle input. So for example this. So hash are walls, dots are paths, open paths, and then start and end. When a program runs through the racetrack, it starts at the start position. Then it is allowed to move up, down, left or right. Each such move takes 1 picosecond. The goal is to reach the end position as quickly as possible. In this example, racetrack, the fastest time is 84 picoseconds. Because there is only a single path from the start to the end, and the programs all go the same speed, the races used to be pretty boring. To make things more interesting, they introduce a new rule to the races. Programs are allowed to cheat. The rules, for example, are very strict. Exactly once during a race, a program may disable collision for up to 2 picoseconds. This allows the program to pass through walls as if they were regular track. At the end of the cheat, the program must be back on normal track again. Otherwise, it will receive a segmentation fault and get disqualified. So a program could complete the course in 72 picoseconds, saving 12 picoseconds by cheating here for the 2 moves marked 1 and 2. Or a program could complete the course in 64 picoseconds, saving 20 by cheating for the 2 moves marked here. That one would save 38. And then this one saves 64 picoseconds and takes the program directly to the end. Each cheat has a distinct start position where the cheat is activated, just before the first move that is allowed to go through walls, and end position. Cheats are uniquely identified by their start position and end position. In this example, the total number of cheats grouped by the amount of time they save are as follows. There are 14 which save 2, 14 that save 4, 2 that save 6, 4 that save 8, 2 10, 3 12, and there's 20, 36, 38, 40, 64. You aren't sure what the conditions of the racetrack will be like, so to give yourself as many options as possible, you'll need a list of the best cheats. How many cheats would save you at least 100 picoseconds? Okay, that sounds like an interesting challenge, so I guess let's get started. So like many of the challenges in this, we will need to create a grid. This will be list of runes. This will be the length of lines. We also need start and end positions, which we have the point for. Make sure that's the correct one. That is correct. So for y line in range lines, lines, we then do grid y is equal to list of rune on line. Now we need to see if we have an S or an E here. So for x character in range line, if car is equal to s, then start is equal to point xy, and then we do same thing, but else if it is an e, we do xy. So let's do, just to make sure we've got everything all set up correctly, print line grid, and then we'll do start end. That appears to be correct, but let's double check. Although it says the end is 0 0, which is definitely wrong. It's interesting looking at the side thing here of what the map looks like. So it's just a massive there's a massive wall right there, but as we saw in here, it didn't come out correctly. So why wouldn't that happen? Do I need to maybe, I don't know, do a separate if like that to get it to work? No. So why aren't you working? Oh, okay. Of course. There we go. Change it back to here. There we go. Now it's working. So we've got our start and end. Now it's so this is an interesting challenge. So first, you are trying to go from S to E, like basically all of the other challenges we've done. So you navigate through it. What you then do is keep track of every step of the way to E, and then you kind of go through and you go, on this location, can I go 2 spaces out or whatever? And then you navigate through them And you do that until you are more than 100 less than what you're aiming for. So if you get to more than 100, then you go, okay, this is not the solution. Then you kind of go to the next one. And keep doing that, trying to solve your way through the maze. Okay, I think, yeah, that's how we will do it. So we've got all this. We also need directions. So that's, we'll do list of point. So we'll do up, which is point, I could do that up as point, where so x, so 0, -1. Then we can do right, which is 1, 0, down, which is 0, 1, and then left, which is -1, 0. And I wrote that incorrectly, so like this. So we've got our directions now. Okay, so what exactly are we doing? How many cheats would save you at least 100? Okay, so that's what we're looking for. So it's the total amount. So I guess let's try to find code we already have, which is, do we want, okay, we want this kind of, so we'll go back to here, and we'll name this one state D20. So we've got position, direction, don't need direction, but we'll have score, and tiles like this, that works. And then when we find the shortest one, that's what it would be. Let's take a look at 16 again. Yeah, but it was all that. We will keep track of previous positions, although this one can just be a point. We will bring back this lost state as we're trying to find the shortest path, and that I missed creating the queue right here, which we need. This will be D20, and our D20 starts off with point. Okay, yeah, that works. Point, score. Actually, no, we don't need score. We just need tiles, because we can then use the length of the tiles for that. And for this we can do length of min tiles is equal to 0, or we then do these two again, but we s tiles length is less than that, and then do min is equal to s, but we need to, firstly let's change this to D20. Oop, D20 and D20. That looks correct. So we've got that lowest state. So we got you, and that's all this. So let's copy all this and we will change it as we go. So doing for, and let's do shortest state var state D20. So do get lowest if current position equals end. Shorter, didn't mean to go all the way back up. We then go shortest state is equal to current state, and we break if previous positions, so that'll be current state like this. Don't need all of that, just need this. If current state dot position, if we're already been to this current position, we continue, and if that's not the case, we then do this and equals true. And what's this left key? Okay, we don't need all this stuff which we were doing before. Okay, I need to change some of this. We can do, whoop, didn't mean to run that. For underscore in range directions. Next is equal to, we'll call this next state is equal to state D20, where there's a point which is current state position x plus dot x, and this now for y. So we've got this, and then we do current state tiles. Actually, we'll change this to next point is equal to this, just so it's a bit clearer. Next point this. Then it'll be append tiles with next point. Okay, so we've got you. Now we do, what should we look at? Actually, we will add this into here, because we want everything in our queue to be a valid pathway. So if next state position, continue, then we do if grid next state dot position dot y, then same thing again, dot position dot x is equal to hash, continue, and then if that is all good, we then do queue append like so, and we do connect state. So we can get rid of all this extra stuff like pasted in. And just to see if this works, let's do output is equal to length of this dot tiles. But I should also grab this as well so we can see how things work. Okay, we're going to stop that and we will put this one in. Okay, it seems like it's running infinitely. So let's put a breakpoint here and see what's going on. Q has a ton in it. What does current state look like? 3, 1. Okay, so it's not moving. So that means I did something wrong. So next point plus the that seems to be correct. Okay, maybe let's just do this. So for the then create next point. So 3, 0, we can't go that way. We want it to be 2, 1. So that fails. No, that one succeeded. This one fails. So we go to here. 1, 0 for direction. 4, 1. We don't want that because this is the one that we would want. Wait, no, I may have got things mixed up. Wait, so what's current? 3, 1. Okay, no, wait, that's here. X of 3, thing of 1. So then that one should go to here, which would be work. I pressed that. Current state. The 1, 1. Okay, we can clearly see it's not working here. Okay, maybe this does. We put that here, but then also put it in here. Oh, I removed where it actually gets added back in. Okay, we'll do this. It's equal to true. I forgot to add that in. So now I'll run that. This should hopefully work now. 84. So that's the original one. It's the original one at 84. Okay, yes it is. So if we switch to our real input, what do we get? Okay, we've got this number. So we are reaching the end. We have that working. We now have max tiles is equal to this minus 100. Let's do, I don't know, correct tiles. I don't know what to call that, but we'll just do this. Then feels wrong doing this, but I might just copy this for loop again. Okay, just thinking about we need in the state, we need to include cheated as a boolean. So this will be false. No, that needs to be inside of here. False. And false. And current state dot cheated as well in here. None of the examples are showing just like cutting over 1. So does that mean we can only do 2 at a time? So you may disable collision for up to 2 picoseconds. Okay, so I decided to stop recording because it was taking too long and I knew there was a bunch more I needed to do. But as you can see from this right here, we can see that we now have, let me just reprint that, we now have the correct output. So one thing which got me confused, I thought it was saying you could skip 2 of these, but that's not the case. It's like 1, 2, that's actually just going over 1, and all these examples you can skip 1 wall, so the wording confused me there, so I've had to comment all this out, but I might as well just delete it all now. I can't remember what point I got up to before, but I basically just cleared a ton of stuff, so it's all basic, just position tiles, don't need to keep record of anything else. And then down here, this main one, I was originally handling state and all that, but state was not needed, so just keep it on the point. So we're just doing points for all of this. So essentially we're starting on a point, we're going in a direction. If it's not a wall, we skip it. Then we go to here, we then try all directions again. Firstly, if it's on the current tile, then over the previous tile, I guess, we skip that. But then we're looking for the one which is not a wall, and then we're adding that in. So we have this now, and to get the actual, I need to change this. So I was testing with the original one, with the example one, which was 84. So now I need to remove that. So now we're looking for maximum total minus 100. I was also doing some weird stuff with how I was recording tiles, which I was lucky that actually worked. Don't know how it worked, but I was lucky it did. Had to change a bunch of that. Let's remove this. And from the looks, okay, I need to actually change how we're recording with the map. So for and total in range cheated output plus equals total. I think that will give us the correct output. It was actually after the okay, that looks wrong. Well, after is 14, 14, 2, 4, 2, that. Let me just change this to KV. That's format.print. KV. Change this to V. Oh, right, I switched to the real input. So maybe, let me just quickly change this. Switch to the test one. And what? 28, 30, 28, 30, 34, 36, 39. Well, that should be 44, I think. Alcohol, I'm getting 0. That makes sense why I'll be getting 0 because I removed this. So let's just do this again. I just want to be certain I get the correct answer. 44. Okay. So we may have actually been getting, might actually have it correct now for part 1. 1436. Let's see if that is correct. And it's too low. Good fun. So something that could be the case. Let's go to here and just do a print for a few things. So format.print. Let's just get all these. So we are going to do this first. Then we will do total. Then we will do max tiles. So that number does look correct. Let's try cheated. Okay, well there's apparently one which saves almost the whole thing. So let's see if we can find that. So they're all kind of up here, I think. We were S. You are there. E is not too far. Okay, well, not really sure what to do to fix this. So let's say 1436. Is that I think that's the number put in, but let's try 99. Let's play around with these numbers a bit. 1463. So 1463, 1436. Let's try 101. 1436. And the number put was too low. So maybe I needed to do minus 99. 1463. Okay, there we go. That's the correct answer. This part 1 is taking me so long, and I'm just hoping that part 2 is easier. So I'll start that now. The program seemed perplexed by your list of cheats. Apparently the 2 picosecond cheating rules was deprecated several milliseconds ago. The latest version of the cheating rule permits a single cheat that instead lasts at most 20 picoseconds. Okay, so now in addition to all the cheats that were possible in just 2 picoseconds, many more cheats are possible. This 6 picosecond cheat saves 76 picoseconds. Because this cheat has the same start and end position as the one above, it's the same cheat, even though the path taken during the cheat is different. Okay, so cheats don't need to use all 20 picoseconds. Cheats can last any amount of time up to and including 20 picoseconds, but can still only end when the program is on normal track. Any cheat time not used is lost. It can't be saved for another cheat later. So you'll still need a list of the best cheats, but now there are even more to choose between. Here are the quantities of cheats in this example that save 50 picoseconds or more. And it's again how many cheats would save you at least 100. Okay, this complicates things a little bit, because now there's a ton of different ways that you can do it. So for each position you are within the maze, you can use 20 picoseconds of cheat. So that is basically a ton of different ways that you could navigate through. Okay, well I guess let's get started. Okay, so far I've got it copied in, but I just thought of how we could do this. So there is a maximum of 20 that we can move. So that means we can, I'm trying to think, what's the furthest we could move? So we could like go to the left 10, we could go up 10, we could go to the right 10, we could go up 10, and same thing. So we could think of it as we're in the center of a grid, or we're in the center of a 20 by 20 grid, which is where we can move. We just go through that grid, looking at each of the positions, and if it lands on a part of the path, then if it lands on the path, then we check to see if it's less than, then we can move. So that will make things a lot easier, and it's something that I could have actually just done for the first part. So we don't need to, we don't need really much of this. So we do for y is equal to negative 20, y is less than or equal to 20, y plus plus. Now for, is that correct? Yes, that's correct. I was just thinking, it's not that we're going 20 in one direction, it's, actually, I guess we could. Okay, so I realised what it needs to be. So we're gonna do this, but we then need to do math to see, okay, is the combination of these two numbers greater or less than? the number. So we've got our two things. We need to, let's do y abs is equal to math.abs y, then x abs, same thing with the x, and okay, that needs to be a float 64. Float 64 to do this. Actually, no, we could do this here, and then what would this have to be? Would have to x is, how do we do this? So let's say max x is equal to the absolute of this, then 20 minus this. Then we do minus this and less than this. So if I had 20y, the x can't move at all. But then as we start changing the amount of y we're doing, then we can start expanding on x. So we do this. Next, actually we don't need directions at all now. We are using purely x and y. So I've got all of this. We now put it into here. Now let's do, now it's just x and y. And I should change this to int. And all we need to do now, so we do that, leave, and if it's equal to hash, we exit. We don't need any of this stuff anymore. It is only this we need, and not even this if statement. We just need this part. So current tile count is this plus y plus x. Skip tile count, next point, skip, and then I think that's all that's needed. So now if we switch to this one, change what's used for this. Here are the quantities of cheats in the example that say 50 or more. We'll just change this back to, we will change this to just total tile so we can see everything. Right. Cool, apparently my part 1's broken now. Okay, that makes sense, because I didn't actually change that. But what I should do here is format.print and print cheated. So 76 is 3, 74 is 4. That looks like we have the right answer. So let's go back to here, remove this, and switch back to this, and hopefully we've now got it right. Okay, we've got a number. Let's hope it's finally done. The number is too high. Okay, so I've spent absolutely ages on this. I can't remember what exactly I've changed since I was recording, but I think the main issue was just this. I needed to do the absolute value of y and x, as if they had a negative number, then I was just removing it from it. But I seem to be getting the right number now, 32, 31, 29, and all the way up. So let's hope that is finally done. So we'll change that. Then we'll also go up to here, change this, and now run it. And we now have this number, which seems to be promising, because the first time we ran it was like 1 million something, and it was too high, then it was, but it was very close. So I think this is the right number. So let's submit that, and hopefully it's done. And that is the right answer. That took me far longer than I thought it would, and it was just my own mistakes for why it was taking so long. So yeah, if you like this video, make sure to like and subscribe.